The Osprey was the world's first production tiltrotor aircraft, with a single 3-bladed proprotor, turboshaft engine, and transmission nacelles mounted at each wingtip. The aircraft is classified as a powered lift aircraft by the Federal Aviation Administration. For takeoff and landing, it usually operates as a helicopter with vertical nacelles and horizontal rotors. Once airborne, the nacelles rotate forward 90 degrees in just 12 seconds for horizontal flight, turning the V-22 into a more fuel-efficient and higher-speed aircraft, much like a turboprop aircraft. STOL rolling takeoff and landing capability is achieved by tilting the nacelles forward up to 45 degrees. Other orientations are possible. Pilots describe the V-22 in airplane mode as comparable to the C-130 in feel and speed. It has a ferry range of over 2,100 nmi. Built with two Rolls-Royce AE1107C Liberty turboshaft engines, the Osprey can go very far and very fast. Top speed reaches 500 km per hour. And the maximum range is 1,627 kilometers. Its amazing features don't stop there. Ospreys can fly up to more than 7,000 meters with a climbing speed of 963 meters per minute. Composite materials make up 43% of the fuselage, and the propeller blades also use composites. For storage, the V-22's rotors fold in 90 seconds and the wings rotate to align, front to back, with the fuselage. Due to the requirement for folding rotors, the 38-foot diameter was 5 feet less than the optimal size for an aircraft of this size to perform vertical takeoff, resulting in high disk loading. Most missions use 75% or more fixed-wing flight, reducing wear and tear and operational costs. These fixed-wing flights are higher than typical helicopter missions, allowing long-range line-of-sight communications for improved command and control. Exhaust heat from the V-22 engine could potentially damage a ship's flight deck and coating. Navarre designed a temporary fix to the portable heat shield placed under the engines and determined that a long-term solution required a deck redesign with heat-resistant coatings, a passive thermal barrier, and changes to the ship's structure. Similar changes are required for F-35B operations. In 2009, DARPA requested a solution to install a powerful flight deck cooler. A heat-resistant anti-slip metal spray called Thermion was tested on the USS Wasp. The V-22 is equipped with a glass cockpit, which combines 4 multifunction displays, MFDs, compatible with night vision goggles, and one central display unit together, to display a variety of images including digimaps, imagery from the turreted forward-looking infrared system of the main flight instruments, navigation, TACAN, ILS, GPS, INS, and system status. The Flight Director panel on the cockpit management system allows a full pairing function, autopilot, that brings the aircraft from forward flight to an altitude of 50 feet without any pilot interaction other than programming the system. The V-22 can be armed with a single 7.62 by 51 mm, .308 caliber, M240 NATO machine gun or a .50 caliber, 12.7 mm, M2 machine gun in the rear loading ramp. The GAU-19 3-barreled 12.7 mm, 0.50 in, Gatling gun mounted under the nose was studied. BAE Systems developed a remotely operated, belly-mounted gun turret system, the Interim Defense Weapon System, IDWS. These are operated remotely by the gunner. Targets are acquired via a separate pod using color television and forward infrared imaging. In November 2014, Boeing conducted self-funded weapons tests, equipping the V-22 with forward fuselage pylons and replacing the N/AAQ-27AEO camera with a Wescam MX-15L 3 sensor/laser designator. 26 guided Hydra 70 rockets, 2 guided APKWS rockets, and 2 Griffin B missiles were fired in 5 flights. The USMC and USAF sought a nose-mounted weapon connected to a helmet-mounted sight. Recoil is complicated by integrating a forward-facing weapon. A pylon can carry 300 pounds, 140 kilograms, of ammunition. However, in 2019, the USMC opted for an IDWS upgrade rather than adopting a new weapon.